linearly dependent functions, a set of functions. Like what? Like f1, f2, and f sub n are called linearly dependent on an interval like I. If we can find some constants that not all of them are equal to 0. Constants like C1, C2, Cn, which not all of them are 0. And we have the following case. If we form the linear combination of these functions, C1 f1x plus C2 f2x plus Cn fnx, this linear combination becomes 0. So this is our linear combination. Give us an example. Let's go over a very simple example. Check if f1x equals to x squared and f sub 2x equals to 5x squared are dependent or not, linearly dependent or not. So, can we find C1 and C2 such that C1 and C2 are not 0, but the linear combination of these two becomes 0? Can we find C1 and C2 such that C1 f1 plus C2 f2 becomes 0, while C1 times x squared plus C2 5x squared is equal to 0. This is simple algebra. Of course, if I plug in -5 for C1 and 1 for C2, these two become opposite of each other. You have -5x squared plus 5x squared, which is 0. Since we found C1 to be -5 and C2 to be 1, they are linearly dependent. So I expect you to ask, well, do we have any shortcut to help us show that functions are linearly dependent or not? In this case, we're going to use the Wronskian of these functions and their derivatives.